All right, find absolute extreme values of f of x equals x 4x over x plus 1 on 0, 3. So again, I'll give you a few minutes. This problem is slightly more difficult than the previous one. And I want to make sure that you actually ask the following question to yourself. Don't answer this question in chat. I want everyone to actually think about this. So is f continuous? If not, remember, the extreme value theorem does not apply to a discontinuous function. So then that means our algorithm for finding mins and maxes would not apply. Our algorithm that we're using in today's lecture only applies if the function's continuous. So I'll give you, I never actually, this is again, because I never copied it. I'm going to again put a timer on the screen. Let's do 6 minutes. And again, I'll do a poll. And as you finish the problem or as the timer kind of winds down towards the end, then you can answer the poll. How would you know if it is continuous? So we actually did cover back in section 2.3 what it means to be continuous. Remember, the idea is function is continuous at the point x equals c if this is true. That is the condition for continuity. So all these things have to exist. F of c has to exist, and this limit has to exist, and then both of those values have to be the same to have continuity. Screen just temporarily. Everything can be on the screen. So I'll make the poll active. But again, if you're not done working on the problem, just wait to answer the poll. Okay, so timer's almost up. So if you haven't answered the poll yet and you want to, just make sure you respond to the poll. Okay, so the results of the poll are a little bit different than the last time. So 45 out of 68 people, 47, 48, so a few more responses are trickling in. So these are approximate percentages because they are changing a little bit. So 10%, now it's 12%. So 12%, 22%, 18%, 13%, and 9%. Doesn't add up to 100 because the remaining just didn't answer the poll. Okay, so that's kind of where we stand. So first, let's start with, so if you did not sure how to start, right? Make sure that you understand that this algorithm that's at the top of the screen, this applies no matter what the function is, right? There's no exceptions. You always start these problems, you find the absolute extreme values of this function on this interval. They start off all the same way. They always follow all 4 of these steps. The only thing that is really different about each problem is in the first step, obviously the function's different, so the derivative will be different, right? Maybe you'd use product rule or quotient rule. And then you have to solve the equation f prime equals 0. So maybe there's a little bit extra algebra to do there. But the fundamentals never change. Now, for the students who actually said choice B, I can start but can't get the critical numbers. I'm guessing that you knew how to start, but the algebra was messing you up with the equation f prime equals 0. Right, so we'll do the algebra a little bit slowly. Okay, so first of all, is f continuous? Let's answer that question. So is this problem, was the whole thing actually one big trick? Did I really give you 6 minutes just for you to figure out that the function was discontinuous and then you just sat there for 6 minutes because the problem was just you can't do it? Remember, if the function's not continuous, there's nothing to do. EVT doesn't apply, and I can't do this algorithm. So who wants to actually answer that question? Like I said, don't necessarily trust the results of the poll, even though some people obviously did not answer choice C. Maybe that answer, maybe it really is discontinuous. Angelica, you want to
Isn't
take
it
that?
like, yeah, isn't it like not continuous when like x equals -1, but that's not even in the interval?
Okay, that's actually 100% the correct answer. So this function is not continuous, and it fails to be continuous at x equals -1. So note, f is not continuous at x equals -1. Right? Why is the function not continuous at x equals -1? Well, the function is not even defined at x equals -1, right? Because you get division by 0. So that limit definition of continuity is obviously false if c equals -1, because f of -1 doesn't even exist. But then what Angelica said after that is completely correct. Even though the function is not continuous at x equals -1, we don't care, because -1 is not in the interval. So EVT does apply. For instance, if the interval were not 0, 3, if the interval were, say, -5 to 3, then you can say, this function is not continuous at -1. -1 is in that interval. Therefore, I can't apply this algorithm. So either the question's a trick, or I really can't do this problem. Right? Remember, if the EVT does not apply, the min and max may not even exist in the first place. Right? The EVT guarantees the min and maxes exist. Right? It kind of tells you, oh, the problem makes sense. Right? I see Victoria typing. I think Victoria's a question. So just keep typing your question. I'm going to move on, but I'll answer your question once you type it. So now we find the critical numbers. Now that we realize, okay, the question makes sense. Oh, I answered it. Okay. So even though the question does make sense, now let's go on. So find the critical numbers. Remember, there are 2 types of critical numbers. F prime of x does not exist, and f prime of x equals 0. Right? Those are the 2 types. So where does f prime of x not exist? So who wants to answer that one first? where does this function not have a derivative? Ooh, did I stump everyone?
Isn't it like just when x is -1?
That's correct, except, like you said, we don't care, right? X equals -1, but -1 is not 0, 3. So that actually gives us, so the real answer to that question is none, right? Because -1 is not in the interval. Okay, now let's do the derivative and set it equal to 0. I have both of them on. Okay, the original function is at the top of the screen. So getting this derivative, we're going to need quotient rule. So 1 minus denominator x plus 1 squared. So bottom, derivative top, minus top, derivative bottom. And I set that equal to 0. So let's simplify this first. So what does this numerator simplify to? I get 4x plus 4 minus 4x. So the 4x's cancel out. So I'm left with 1 minus 4x over x plus 1 squared equals 0. And so for those who answered part B that you knew how to start but you couldn't find the critical numbers, if the reason you answered that was because you couldn't do this algebra, sorry, this should only be a 4, not a 4x. Right, make sure you're practicing algebra, right? Algebra is something you have to know. This is not, it's just like taking derivatives. You have to just know it. It's just a basic skill you must know. So in this case, what you can do is you can just move the fraction over to the other side and then cross multiply, get x plus 1 squared equals 4. Then now to get rid of the square, I can take a square root. So that gives me two possibilities. Either x plus 1 equals -2 or x plus 1 equals +2. Right? Make sure you actually get both of those. Don't just get this, right? The x plus 1 equals 2. But when you take a square root, you can get either of the two square roots because you're looking for what are all the numbers whose square is 4. And -2 and 2 are both such numbers. If I asked you what is square root of 4 with that symbol, that is only 2. Right? Make sure you understand the difference between asking me to solve the equation x squared equals 4 and giving me the square root of 4. Okay, so this gives me x equals -3. This gives me x equals 1. However, after having said all that, it turns out that the other solution, x equals -3, we don't actually care about because it is not in the interval. Remember, the interval that we're interested in was the interval 0, 3. Critical numbers of f. That means it's x equals 1 only. Notice this problem, you might have thought that x equals -1 was a critical number, but it can't be because that's not in the interval, so no good. And you might have thought that x equals -3 was a critical number, but again, no good, not in the interval. Right? The only critical number here was x equals 1. Okay, now we make a table of values. So x and y, and the original y was x minus 4x over x plus 1. Okay. And so what are the x values I need to put here? Who can tell us what x values I need to substitute back into the original function? 1, 0, and 3. Good. 1, 0, 3, 0, 1, 3. Good. So we get 1 because that was our critical number, but then 0 and 3 we have to check because those are the endpoints of the original interval. So this is a critical number. I'll write that. And these two are endpoints. Okay, so doing this arithmetic, substituting in 1, I get 1 minus 4 over 2. So I get -1. And substituting in 0, I get 0 minus 0, 0. 3, I get 3 minus 12 over 4. So I get 0 for that as well. Okay, and then so what do I put in my answer box? So absolute min, absolute max. So just very quickly, what do I put in these two answer boxes? -1, 0, max 0, min -1. Good. All right, the absolute min is -1, and the absolute max is 0. All we're looking for is we're looking at these three numbers, right? So -1 is clearly the min, and 0, they're both the max. So keep in mind that the actual value is unique, right? There's one absolute minimum, and that's -1. There's one absolute maximum, and that is 0. However, they can occur at multiple x values. So this is a case where we see the absolute maximum occurring at two different x values. And that's perfectly fine. So if I also ask for the x values, I would say, okay, absolute min of -1 at x equals 1, and absolute maximum at 0 at x equals 0 and x equals 3. That's perfectly fine to have multiple x values. In fact, what would that look like graphically? This function passes through 0, the origin, 1, 2, 3, passes through the 0 there, and it's -1 here. So this function looks something like that. All right, so there's a minimum at x equals 1, and there's a maximum at x equals 0 and x equals 3.